That's where we talk about implicit differentiation. Our steps in implicit differentiation is that you will take the derivative of both sides of an equation, keeping in mind that y is a function of x. Then rewrite the equation so that the terms on dy dx is on the left side and the other terms without dy dx are on the right. And you factor out your dy dx on the left side if needed, and then solve for dy dx using appropriate algebra, simplifying as much as possible. Now, in terms of implicit differentiation, the first derivative, as usual, is the gradient of the curve. The gradient at a point is found by substituting the x and y values into the gradient of the curve, dy dx, which we found earlier. The equation of the tangent line at a point is found by using the gradient of the points and the x and y values, y equals mx plus c equation. And then the equation of the normal is found by using the negative reciprocal of the gradient of the tangent line in the y is equal to mx plus c equation. So we're going to write our answers in gradient intercept form. Now let's look at an example. The curve C is given by 2x squared plus xy plus y squared equals 10. A, find dy dx. B, find the tangent line at 2, 1. And C, find the normal line at 2, 1. So we're going to be writing the tangent line and normal line equations. First, let us look at our curve. 2x squared plus xy plus y squared is equal to 10. We want to take the derivative of each term. So we have d dx of 2x squared plus d dx of xy plus d dx of y squared equals d dx of 10. When you take the d dx of 2x squared, we get 4x. For the xy, it is a product, so we have to apply the product rule. So we're going to take x times the d dx of y plus y times the d dx of x plus the derivative of y squared, that's 2y dy dx, equals the d dx of 10. The derivative of 10 is 0. So remember the constant rule. Next step, we're going to simplify and then put like terms together. So we have 4x plus x times dy dx, and then plus y plus 2y dy dx. So this plus y, because that's y times d dx of x was 1. Okay, equals 0. So continuing down, you're going to try to put the dy dx's together and everything else on the other side. So we have x times dy dx plus 2y dy dx is equal to the negative 4 if you subtract negative 4 and the minus 2y from both sides. 0 minus 4x minus y. That's going to be negative 4x minus y. Factor out the dy dx on the left side. You're going to have dy dx bracket x plus 2y close bracket. That's equal to negative 4x minus y on the right side. And then divide both sides by x plus 2y. We have dy dx is equal to negative 4x minus y over x plus 2y. Now at 2, 1, our gradient m, which we have dy dx here, is going to be equal to plugging in for the x and y. So that's negative 4 times 2 minus 1, that's for the y, and then over 2, which is the x, plus 2 times 1, which was the y. So negative 4 times 2, that's negative 8 minus 1, that's negative 9. And then in the denominator, 2 plus 2 is equal to 4. So your gradient is negative 9 over 4. For the tangent equation, we're going to use the gradient of negative 9 over 4. Put that into the y is equal to mx plus c along with the x value and the y value of 1, x value of 2. So 1 is equal to negative 9 over 4 times 2 plus c. 1 will be equal to negative 9 over 2 plus c Then c will be 1 plus 9 over 2, and that's going to be equal to 11 over 2, right? So your equation of your tangent line is y is equal to negative 9 over 4x plus 11 over 2. All right. A normal equation is negative reciprocal gradient of the tangent, because the tangent was negative 9 over 4. Then your normal gradient would be flip that over and take the negative of it. That's going to be 4 over 9. Put that into y over mx, y equals mxc, mx plus c equation. We have 1 is equal to 4 over 9 times 2, which is your x plus c. So 1 is equal to 8 over 9 plus c. So subtract 8 over 9 from both sides. 1 minus 8 over 9 equals c. So c will be equal to 1 over 9. So our normal equation will be y is equal to 4 over 9x plus 1 over 9. So look at another example. The curve c is given by x squared plus xy plus 3y squared is equal to 15. A, find dy dx. B, find a tangent line at 3, 1. And C, find the normal line at 3, 1. So looking again at our equation here, x squared plus xy plus 3y squared is equal to 15. To find dy dx, or the derivative, we take the derivative of each term in the equation. So the d dx of x squared plus the d dx of xy plus d dx of 3y squared equals the d dx of 15. Now note again in the middle, x times y is a product, so we have to use the product rule in the middle right here. But for the end, the d dx of x squared was 2x. In the middle, x times d dx of y plus y times the d dx of x plus, at the end here, the derivative of 3y squared is 6y dy dx. And derivative of 15 is equal to 0. Then we have 2x plus x dy dx plus y times 1, which is y, plus 6y dy dx is equal to 0. Then bringing terms with dy dx together, x times dy dx plus 6y times dy dx is equal to negative 2x minus y. And so factoring out dy dx, on the left side we have dy dx times x plus 6y is equal to negative 2x minus y. And then dividing through both sides by x plus 6y gives you dy dx is equal to negative 2x minus y over x plus 6y. Now for part B, we want to find the equation of the tangent curve. So then at this point, 3, 1, so you plug in 3, 1 into your dy dx formula. So dy dx is equal to negative 2 times 3 minus 1, which is what we substitute for the y, over 3, which should substitute for the x, plus 6 times 1, which should substitute for the y. Simplify that, gets your derivative equation, or your gradient of your tangent line. We could call that m is equal to negative 7 over 9. So your tangent equation, plug that m is equal to negative 7 over 9 for m, and 1 for y, and 3 for x. So 1 is equal to negative 7 over 9 times 3 plus c, and simplifying that down, 1 is equal to 7 over 3 plus c, because 3 divides the 9 3 times. And then c is equal to 1 plus 7 over 3 by adding 7 over 3 to both sides. And so c will be equal to 10 over 3. So your equation is now y is equal to negative 7 over 9, x plus 10 over 3. Now for your normal line equation, remember your normal line is negative reciprocal slope of your tangent line, and your tangent was negative 7 over 9, so your gradient of your normal line is positive 9 over 7. So then plug that into the y is equal to mx plus c equation. 1 is equal to 9 over 7 times 3 plus c. So then y is equal to 27 over 7 plus c. So subtracting 27 over 7 from both sides, I have c is equal to 1 minus 27 over 7. So c will be equal to negative 20 over 7. So the equation for your normal line is y is equal to 9 over 7x minus 20 over 7. Let's look at our third example. The curve C is given by x sine of y plus y cos x equal to a, find dy dx, b, find the tangent line at 0 pi over 2, and c, find the normal line at 0 pi over 2. So then we have our equation x sine of y plus y cos x is equal to 2. Taking derivatives of each term, we have d dx of x sine of y plus d dx y cos x is equal to d dx of 2. Now notice both terms here, they are products. So we got to use a product rule on each of them. So we have x times d dx of sine of y plus sine of y d dx of x. That's a product rule for the first term above. And then plus y d dx cos x plus cos x d dx of y. That's a product rule for the second term above. Equals 0. That's the d dx of 2 is equal to 0. Now then, x cos y dy dx plus sine of y plus d dx of negative sine plus not d dx but y times negative sine of x plus cos x dy dx is equal to 0. All right, bringing the dy dx's together, factoring out. We have dy dx times x cos y plus cos x, then plus sine of y minus y sine of x is equal to 0. Bringing everything else except dy dx to the other side terms. We have dy dx x cos x y plus cos x is equal to y sine of x minus sine of y. And then finally dividing both sides by x cos y plus cos x, we have dy dx is equal to y sine of x minus sine of y all over x cos y plus cos x. So that's your first derivative of the curve. We're trying to find the tangent line in part B, the equation of the tangent line at pi over 2. So we at 0 and pi over 2. So I plug in those into the gradient function. We have dy dx or dx is equal to pi times sine of 0 minus the sine of pi over 2 over 0 times the cos of pi over 2 plus the cosine of 0. That will simplify to give pi over 2 times 0 minus 1 over 0. This should be times 0 plus 1. So it's negative 1 over 1. That is equal to negative 1. So your gradient is equal to negative 1. Then plug in the m equals negative 1 and the 0 for x and pi over 2 into the equation y is equal to mx plus c. You'll have pi over 2 is equal to negative 1 times 0 plus c. So c is equal to pi over 2. So our equation will be y is equal to negative x plus pi over 2 for the tangent line. Now for the normal line, the gradient of the normal line is negative reciprocal of the gradient of the tangent line. So the gradient of the tangent line was negative 1. So then the gradient of the normal line will be positive 1. So put that into the y equals mx plus c equation. So we have pi over 2 is equal to 1 times 0 plus c. So c will be equal to pi over 2. So then our equation for the normal line is y is equal to x plus pi over 2. Thank you. The end.